Hey guys, today we are looking at pairs of lines and angles, and we're going to learn some more vocab to go along with these. So we're going to start with talking about how lines can intersect or not intersect, and how planes can intersect or not intersect in those special cases. So two words that I think you already know are that two lines can be perpendicular. There are lots of examples in here. We're going to assume that this is a cube, that all of those are right angles in there. So you can come up with your own example. Two lines that I see that are perpendicular are MC and CR. So think of the top of the box. So it doesn't really look perpendicular to our representation, but if we're thinking about the top of the box, those would be perpendicular. So MC, and I'm going to put the segment bar above it since it is just a segment there. And then remember that perpendiculars are upside down T, and then CR with the segment bar above it. You can pick out another example if you like. MC and CG would also be perpendicular. MC and MH would be perpendicular. Lots of options there. Okay, two lines can also be parallel. So if I use MC again, and I want to remind you, parallel means that they're never going to meet. So here's MC. A line that is parallel to MC would be AR. If we're talking about the top of that box, those lines are never going to meet. And so our symbol for parallel is these two bars. And we put AR, so the top of the box. MC and AR. Again, you can come up with more examples. MC and HG would be parallel, the side of the box. Okay, a new term for you is skew. Two lines can be skew. Skew means that the lines are in different planes and never meet. So one extra condition of parallel is that the lines have to be within the same plane. So we said those two lines are in the top of the box, but they never meet. So again, if we look at MC as one of our segments, then you look at like GN. Those are in different planes, but they're never going to meet. Picture your box, that's the top left-hand side, and then the bottom front. Those two lines will never intersect. They're not in the same planes. They're considered skew. So MC and G, and we don't have a symbol for skew, so I just put an N symbol there. All right, similarly, two planes can be perpendicular. So I'm going to erase this so we can draw on here. Two planes that are perpendicular. Well, if I look at the top of the box, again, remember that when we name planes, we name them with 3 points. So I'm going to call this plane MCR. You could have used A in there instead if you wanted. Is perpendicular, so top of the box, let's say it's perpendicular to the front of the box. Again, you can pick a different one if you want. So I'll say plane, and I need to pick 3 points, so CGN. Planes can also be parallel. So again, if we look at this top of the box, the plane that's parallel to that top of the box would be the bottom of the box. So we'll say plane MCR is parallel to plane HGN. Again, you can pick any three letters. You could have picked the left side of the box and the right side of the box, the front of the box, the back of the box, as different options. Okay, so two postulates. The parallel postulate says if there is a line and a point not on the line, then there is blank line through the point parallel to the given line. So I'm just going to draw this scenario out. If there's a line, I'm just sketching so I don't have a straight edge, and there's a point not on the line, how many lines could you draw through that point that would lie parallel to that given line? The answer there is exactly one line. There's only one line that exists that goes through this point that's parallel to the original line. Perpendicular postulate says if there's a line and a point not on the line, then there is blank line through the point perpendicular to the given line. So how many lines can I draw that go through that point that are exactly perpendicular to the line? The answer again is only one. So exactly one line. Okay, angles formed by transversals. And so transversal is a new term for us. It's a line that intersects two or more other lines in the same plane is a transversal. So in this case, our line that's intersecting two or more lines is right here. Okay, so we're going to talk about some angle pairs. First off, I want to talk about the terms exterior and interior. So I want you to notice in this picture, the angles on the outside are going to be called exterior angles. So that would be angle 1, angle 2, angle 7, and angle 8. Notice those in your picture, why they are exterior angles. They're outside those lines. Then we have interior angles. Those would be angle 3, angle 4, angle 5, and angle 6. Those are on the inside of those lines. So we have 4 terms for angle pairs. The first term is a corresponding angle. So corresponding angles are going to lie on the same side of the transversal. They're made up of one interior angle and one exterior angle. So on the same side of the transversal means I'm looking at angles 1, 3, 5, and 7. So for one of my pairs, if I pick angle 1, that's an exterior angle. Its corresponding angle would be angle 5. And so I think of corresponding angles as angles that lie kind of in the same place. So angle 1 and angle 5 both make that backwards L angle shape. Another pair of corresponding angles would be angle 2 and angle 6. They're in the forward L shape there. They're in the top right of each of theirs. There's one exterior and one interior. Then I have angle 3 and its corresponding angle would be angle 5. And then angle 4, and its corresponding angle would be angle 8. Notice there are 4 of those corresponding angles. Okay, consecutive interior angles. Consecutive interior angles are, again, on the same side of the transversal. But they're both interior angles. So 2 interior angles. So consecutive interior angles. We're looking at the same side of the transversal. If I start with angle 3, there's angle 3, and then I need it to be on the inside and on the same side, so angle 5. My other pair would be angle 4 and angle 6. Okay, then alternate interior angles. They're on opposite sides of the transversal. And they're both interior angles. So if I'm looking at opposite sides of the transversal, and I'm going to erase this so it's a little cleaner, then and I'm looking on the inside, so if I start with angle 3, then I know that angle 6 is the alternate interior angle. So angle 3 and angle 6. My other pair then would be angle 4 and angle 5. Okay, then one last set, alternate exterior angles. Again, these are on opposite sides of the transversal. And they're both exterior angles. So if I have angle 1, we're going to the opposite side. I have angle 8. So angle 1 and angle 8. Angle 2 would pair up then with angle 7. Now be careful because angle 1 and angle 2 fall under that alternate exterior angle. We know those are a linear pair. That's another kind of angle pair. So those are not alternate exterior. So what I want you to do is to try it on your own. And notice those are all mixed up, so they're not in the same spot. But flip back to your notes and the examples that we did together and see if you can come up with those, and we will go over this in class. So that's all I have for you today. Have a great night. As always, come in and see me if you have any questions.